All right, let's continue graphing our trig functions, sine and cosine, but this time let's add that vertical translation. Recall that the graph of a function y equals f of x plus d, or y equals d plus f of x, is translated vertically compared to the graph of just f of x, right? So if I am adding a constant in the front or the back, that constant is going to tell me what vertical translation I'm going to do. If it's positive, I'm going to go up. If it's negative, I'm going to go down. So the translation is up d units if d is greater than 0, and down d units if d is less than 0. So putting it all together, if I have this full equation for sine or even cosine, remember I can pick out the a, the number in front of sine, as my amplitude. I can pick out the b, the number in front of x, which will help me find my period. For sine and cosine, it's going to be 2 pi divided by whatever that b number is. And now, if I have a number added or subtracted to the front or the back, I know this is going to shift my graph up or down. This is my vertical translation, right? All right, so let's do an example here where we're asked to graph this, y equals 1 minus 1/2 sine of x. You can leave it in this order, or if it makes you feel better, you can actually move it around a little bit. You can take that positive 1 and bring it to the back if you'd prefer to see it that way. And you can look at it as a negative 1/2 sine of x plus 1. Okay, now either way, we should be able to pick out all of the important pieces, our amplitude, our period, and our vertical shift from either of those equations. So looking at either of these, I notice that I have an amplitude here, the number in front of sine, of a 1/2, but this time it's a negative 1/2. So what does that mean? Well, if I have a negative amplitude, that really means that I have an amplitude of 1/2, but with a reflection. So everything's going to be kind of flipped over, right? Now, if I'm looking for my period, I know that my period is found with the number in front of x, my b value. It looks like here there is an invisible 1, and so our period here would be 2 pi divided by 1, or just 2 pi. So from 0 to 2 pi, we should make a full cycle through. This one happens to also have this +1 in the back or +1 in the front, however you want to see it, which means I also have a vertical shift. Once I'm done graphing the basic sine graph with my amplitude and period, I have to then shift everything up 1 unit. So we have a vertical shift of up 1. All right, let's go ahead and graph these, and we'll talk a little bit about the domain and the range. I always like to start off with the basic sine graph with the amplitude and the period included, and then shift it from there. So if I know my period is 2 pi, by the time I get from 0 to 2 pi, I need to make one full cycle. So halfway is pi, half of that is pi over 2. So I have 1/2, 2/2, 3/2. These are my 5 points that I'm going to start graphing. Sine always starts at 0. Normally it would go up to 1, but this time we only have an amplitude of 1/2 and it's reflected. So I'm actually going to go down to 1/2 first, then I'm going to go up to 0, then I'm going to go up to 1/2, then I'm going to go down to 0. So if I were just graphing this with the amplitude and period, it would look something like that, right? Now I can continue that going backwards all the way to negative 2 pi. But remember, we still have a vertical shift. We need to take all of these points and we need to shift it up 1 unit, right? So you can copy each of those points and shift those up. I've kind of done this before where I'm going to take my graph and I'm going to shift it up from here 1 unit. So if I'm going from negative 2 pi to positive 2 pi, my final graph would look something like this. Now, they also ask us a few questions about the domain and range. Remember, domain is all the x values. So how far left does the graph go? How far right does the graph go? And are there any issues with my domain? Well, if I were going to continue going on forever and ever and ever, it would continue this periodic kind of cycle, and I would go from negative infinity to infinity on the x. So my domain would be all real numbers, negative infinity to infinity. But this one, the range, remember, is all the y values, how far down, how far up. Because we've shifted it a little bit, it's not going to be the normal -1 to +1. remember there was that original amplitude of just a 1/2, right? So normally we would have gone down to -1/2 and up to +1/2 only. But because there is now that vertical shift where I'm going to shift everything up 1, all of those y values now are shifted up 1 unit. So if I add 1 to each of those values, I end up being the lowest value of 1/2, the highest value of 1.5, or 3/2, right? And that makes sense when you look at our picture, that the lowest this graph is ever going to go on the y value is 1/2. The highest it's ever going to go is 3/2. So that would be my range. You notice that I've used parentheses on my domain for -infinity and +infinity, but brackets around my range values because it does go down and include 1/2. It touches everything in between and goes up and includes 3/2. So I'm going to use brackets on those values. Okay, so there's an example of a sine graph that has been vertically translated.